Right triangle trigonometry. Okay. Label. First thing I'm going to talk about is labeling. When you label a triangle, the angles and the sides, the angles are always written as capital letters. The side lengths are written as small or lowercase letters. They are always across from each other. Okay? So this side here, C. This side, B. And this side, A.
Is this similar to like Pythagorean theorem?
We're getting there. Not similar. It's going to be. Okay? So the first thing that you need to know is you need to know how to label the triangle. All right? I've also labeled one special angle in there. Which angle did I label as special angle?
90-degree angle.
The 90-degree angle, that's the right angle, and that is angle C in this case. Okay? Now, one thing that you need to also know about triangles is that when you look at the size of the angle, the longest side will always be across from the largest angle. Now, if you think about it, what do these three angles add up to in the triangle? 180. So if I have one angle as 90 degrees, both of these angles then have to be smaller. They have to be smaller than the 90 degrees. They can be any measure. They're going to add to give you another 90, but they got to be smaller than 90, right? So therefore, the side across from my right angle, all right, the opposites to this angle, is what we refer to as our hypotenuse. Okay? So I'm going to write that in there like this. Hypotenuse.
The biggest angle. Yeah. So, like, if it was a perfect 90-degree, like, angle, the two angles would have to be 45, right?
Well, it's, no.
Not necessarily.
Listen to
Just one second. I'm just making sure of something here. And I will answer your question.
like, it can still be a 90-degree angle.
Yeah, I
And
guess.
then this one could be like that sharp instead.
Yeah.
And this one
Yes,
would be a
yeah,
little
yeah.
wider.
Didn't look right. That's what you're saying, like, I cannot spell that. That's 30 years this. Hypotenuse. Okay.
I spelled it anyway.
All right. Now, Pythagorean theorem. First thing you've learned so far, right? So you know all about this. The Pythagorean theorem. We take the two shorter sides and square them, and that will be equal to the exact length of my longest side. Squared. A squared plus B squared equals C squared. See it? So far, so good. So up to this point, you all know this, right? You've done this? Okay, perfect. All right, now, we call this a 90-degree triangle. We call this a right triangle. There's a third name for this triangle. Do you know what it is?
Isosceles.
What is an isosceles triangle? That's great. I like that.
Two lengths are the same.
Two lengths are the same, which also means what?
One is different.
No.
I don't
Then
remember.
two angles have to be the same, right?
Oh,
Okay.
so this exact triangle would be an isosceles.
No, because I haven't designated these two angles yet. Okay? The third name for this triangle is a 3-4-5 triangle. Want to know why it's called a 3-4-5 triangle?
Because the Pythagorean theorem looks like is like square.
Because it's the lowest whole numbers that work for Pythagorean theorem. That's right. 3 squared, 9. 4 squared, 16. 16 and 9 make
25.
What's the square root of 25? 5. So this is known as a 3-4-5 triangle because it's the lowest whole numbers that actually satisfy the Pythagorean theorem. All right? So I always take the shorter lengths and square them, and they equal to my hypotenuse length squared. So far, We're all okay, right?
Yeah.
All right. Now, what I'm going to do next, this is new to you. This is going to be new to you, is we are going to talk about ratios. So, how I come up with an angle. The angle is the vertice of those two lines intersecting, correct?
Yeah.
So, what does the width of this angle depend on? Well, it depends on the length of the sides. Okay? The longer the sides, for example, if I increase B and made it longer, what would happen to angle B? As I move it up, what's going to happen to the
It
angle?
would get bigger and
It would get larger, right?
yeah, and A would get smaller.
Okay? So, by increasing the length of the side, I can increase the size of the angle. Fair enough? And vice versa. If I decrease the length of the side, I decrease the amount of the angle. Now, we are going to also label this triangle a little bit different. We are going to talk about trigonometry. So what trigonometry does is it compares two side lengths in order to come up with an angle length, an angle measurement. Okay? So I'm going to take two side lengths in particular, and I'm going to come up with an angle measurement from it. Follow? So I'm going to draw out my, let's do this again. Let's just do this, this, this. All right, I'll put it down here. That's okay. Now I'm going to move it. Just a second. Let me get this figured out. That. Move. There we go. Okay. I'll get this board figured out one day. All right. So I'm going to relabel this again. You've already got it labeled.
Yeah.
Okay. C, B, and A. Now I said that the hypotenuse was directly across from the right angle. Okay? I want to compare the length of this side and that side. Okay? And if I compare them, I should be able to calculate what my angle is here. And I use what we call trigonometry to do that. So I'm going to go like this. The sine of angle B. Now we have three of them. We're going to talk about that actually, you know what? Let me start with this. There are three ratios that we discuss. There's the sine ratio, the cos ratio, and the tan ratio. The sine ratio is it compares the length of the side opposite the angle I'm talking about as compared to the hypotenuse. So we write it out like this, opposite over hypotenuse. So write that down somewhere. Now the side opposite. Look at angle B right here. Which side is opposite angle B?
C.
B.
B.
What is it?
Side B.
Side B. Opposite means across. So what's across from angle B?
Side B.
Side B. Okay? The cos compares the side length adjacent to the angle over the hypotenuse. So the cos compares the side adjacent over the hypotenuse. So it's comparing the two lengths of those sides to get my angle measurement. Now if I'm looking at B now, again, which side is adjacent to it?
C. A.
C could be considered adjacent to it, but we've already labeled it what?
A.
C. No, just wait. Let me talk to Braden here. C could be considered adjacent to it, but we've already labeled it what? Hypotenuse. So what's my alternative side then?
On the C.
A? A. That's right. That's my my adjacent side?
But it's the
To
closest.
angle B. Okay? Because here's how I explain adjacent to people. It's next to it. Here's my angle here. Angle B is right here, right?
Yeah.
What's the side next to it that's not the hypotenuse?
A.
Side A. What's the hypotenuse? C. Never changes. It's always across from the right angle. So far, so good? So the third trig function that we work with is the tangent one. It's going to compare the side opposite my angle compared to the adjacent side. So opposite over adjacent. What side is opposite angle B?
B.
B. What side is adjacent to angle B?
A.
A. So when I compare those lengths, I'm going to use my tan function and I'm going to get my angle right there.
So what?
We'll talk about how to do it all. Just this I need down pat first. All right, let's talk about angle A now. Because things changed now. So in angle A, up here, what's the side opposite angle A?
A.
What is it?
A.
A. What's the hypotenuse?
C.
C. Doesn't change. What is the side adjacent to angle A?
B.
B.
Oh, no.
And what's the hypotenuse?
C.
C. What's the side opposite to angle A? A. And what's the side adjacent? B.
So it's practically just the opposite.
Okay? So, what I'm doing here is just flipping my ratios, okay? Based on the angle that I have determined. So this is all solely based on which angle I have chosen for this to work. So far, are we following? Because this compares the lengths of the sides in order to get the angle. This compares the length of the sides in order to get the angle. This compares the length of the sides in order to get the angle. They all work the same way, but they each have assigned a different trig function to each of the three. So far we're good? Okay? All right, so now, a couple fun facts. Now we ask you, all right, you got to memorize this. You got to remember this. So, math teachers, they're so very clever. They've come up with a way in which you can remember it. One of the ways I've seen, I'm going to show you two of them. There's one of them. Now suck a toe. Sine, opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. Okay? So far, so good?
Yeah.
That's one way to do it. Okay, just don't write this down until I'm done with it, because I got to remember how this works. Okay.
What would be harder? The math like this semester or the math next semester?
Next semester will be. All right. So this one. Here's another clever way of doing it. Two cats sat on an orange and held hands.
Wait, what?
Two cats sat on an orange and have held hands. Try saying that twice fast.
Two cats sat.
On an orange and held hands. Those are two clever math
Is that even possible?
things. If you can't remember sine, cos, and tan.
Must
Right.
be a big orange.
Must be a big orange. All right. So let's have a look. And I'm going to, again, I'm not following anything in particular here in your book. We'll go back and we could answer some questions but I just want to show this to you right now so that when I come back to it after Christmas, it's not brand new to you. All right? So I'm going to show you how this essentially works. Okay. I'm going to label this, okay? Again, I don't have to label it the same way, so I'm going to label it D, E, and F. So for this, I don't need you to write it down. Don't write this one down yet. Okay? Watch as we go through this. All right? So, my right angle is at E, right? Therefore, this side length over here is what? E. And what do we call this side length? That's the hypotenuse. What's this side length? F and D. That's how I label it, right? Okay. So let's do the very, very basic. 3, 4, and what does E have to be? 5. Because 3 squared plus 4 squared equals 5 squared. So there's the very basics of it, right? So far, so good? All right. I want to find out what the measure of angle D is. But in order to do that, the first thing I want to do, I don't have to do this every time. I'm going to do it right now because I'm learning. So what I want to do right now is I want to take all of my 3 ratios and write them down for angle D. And then I'm going to show you how it works, how to solve it. So I'm going to go sine D. What is sine again? Opposite over hypotenuse. What side is opposite angle D?
D.
Which is what measure? 4. 4. And what's my hypotenuse measure? 5. Okay? Cos D. What's the side adjacent to angle D?
F.
Which is? 3 over my hypotenuse, which is? 5. And then I go tan D. So the opposite side is? 4 over my adjacent side, which is? 3. Okay. All right. Now, here's the trick. When doing trigonometry and you're looking for the angle, we use the second function button on our calculator to do it. Okay? So take your calculators out right now. We're going to learn how to use them.
I have some cost.
So you all see that you have a sine, cos, and tan, and they should be in order on your calculator, correct?
Yeah, sine.
So what I want you to do is I want you to hit second function or shift, depending on what it is, and then sine. Now look at the little word just above sine.
M.
The sine button. What does it say?
Sine minus 1.
Sine minus 1,
Yeah,
right? Sine to
sine
the
minus
negative 1?
Yeah.
Everybody sees that?
Yeah.
Okay. You also need to open a bracket up here. You have to have a bracket open.
So what if it already has a bracket like that?
Then you got it open. Right? Now, I'm going to take 4, divide 5, close my bracket, and hit equals.
All right.
53.130. Yeah. So is that actually the angle?
That is actually it.
53 degrees. Holy, that's cool. This surprised me.
Okay?
That's cool.
So far, so good? All right. Now what I want you to do is I want you to check it. Second function, cos now. 3 divided by 5, and make sure you get the same answer.
Yep, same thing.
So cos. Yeah, exact same.
I keep getting 0.927.
Okay, so
You
you close your bracket.
Yeah.
Okay, I'm
Okay.
gonna Yeah, I'm gonna have 2 brackets.
I don't think
Sorry.
closing it
Look,
as
look,
long as you have the one.
No, just hit second.
As long as you have the one that separates them. Because
Anybody else having an issue right now with their calculator?
I got
it. A lot of the time
Wait,
I'll close
I don't-
mine either.
I don't close my bracket and it still works.
I think as long as you have the bracket colliding them.
Whoa, yeah.
What did I do wrong?
All right.
That's cool.
How are we doing? Good. Try it again.
Wait, so
Second function tan, 4 divided by 3, and you should end up at the same angle.
Yep.
there you go.
That's
Oh,
actually cool.
Oh, you got it wrong.
And you get like right exactly.
There you go. Yeah. Okay, you got it right now.
Sorry, Mr.
Your calculator's in the wrong one.
Mr. Newton, what did you tell us to do?
Second function tan, 4 divided by 3. Do we get the same value?
Yes.
Yeah, perfect.
That's cool.
Okay, now, calculate it down for 1 second. Without doing anything else, other than a quick, simple mental math, any idea what f is going to equal?
53.0.
No.
No, well, you 108.
37.
Third,
Go ahead, Haley.
37. I can't remember the decimal.
36.87.
What? How?
Okay,
Because
Oh,
if this is
yeah.
53.13, and this is 90,
then you have
to subtract
Yeah.
those from 180 to get that value right there, correct?
Yes.
Okay, so that's what we think it's going to be, right?
Let's try it.
No, not yet.
Right here.
Let's look at this. Let's use our newfound knowledge to do this. So I want the side of f now. What's the side opposite f?
F.
Value.
3.
3. What's the hypotenuse?
E5.
5. What does f equal? Second function sine. 3 divided by 5.
Sorry.
36.860 or 870.
9.
Well, no, because you got
36.869.
yeah, but you got it's 869. It's irrational.
It's irrational, so you'd round to 87.
That's exactly what I said. I said 36.870.
Is that what we thought it would be?
Yeah, that's exactly what I said.
That's exactly what you
I
said.
said 86.
How did you know it
Okay.
190? 870.
Let's try this again. Cosaf now. What's the side adjacent to f? What's the side adjacent to f?
Four.
Hey, relax. I like it, but just relax. What is the side adjacent to f?
4.
4. What's the height? What's the hypotenuse?
5.
5. So second function.
36.86989.
Got
7, 6, 5.
Okay, you guys. All right, you see what's happening here? I can use any of my 3 trig functions,
No, I'll get the same.
And it'll work all
and I'm going to get the same solution each time. Now, what I would instruct you to do is find it using one of them to begin with. Find the other angle using one of the trig based on the information that you're given, okay? And then if they add up to 90 degrees, you know you got it right. So you can guarantee your work is done correctly. You understand what I'm saying?
Yeah.
This unit is beautiful because you know when you made a mistake and when you haven't. Because Pythagorean theorem wouldn't work for you if you made an error. And the 3 angles wouldn't add up to 180 if you made an error. So if they both work, you know you got the question right.
Yeah.
Makes sense? Okay, I'm going to show you one more and then I'm done for today. All right, so I'm going to go X, Y, and Z. There's my right angle. I'm going to put 6 here. No, let me try this again, sorry.
You got
Same thing.
This is 10.
Then you do a bracket. Then you do the thing. Then you do a bracket again.
All right, so I want you to have a watch now, okay? This again, you may want to write down on paper. Okay, so what you're given now is one angle is given to you, okay? And you're given the length of one side. So you're always asked to find 6 pieces of information. 3 angles in 3 sides. You're always asked to find all of that information. So what am I missing so far? What do you look at my triangle? What am I missing?
3 angles and 2.
No, I've got
One angle.
which angle am I missing?
X.
I'm missing X. And what else am I missing?
2 sides.
Haley?
Side, Z, and X.
Yes. So side Z right here and side X right here. Okay. So the first thing that you can find right away, what's the first thing that you would do? Charlie, what would you do first?
Angles, probably.
Right, because we know that they add up to give you what?
180. Yeah.
Thanks, Charlie. Okay, so what is the answer to this then? What is angle X?
30 plus 90 is 120 and 60 degrees.
So I've got that angle measures 60 degrees right here. Perfect. So I've already got angle X, 60 degrees. There's the first thing I wanted to find. Okay, let's find what side X is now. All right, so here's where we have to talk about this right now. So I want to find side X. I was given angle Z, and I was given 10, which is the hypotenuse. Put your hand down for a second. Okay? I only want to use the blue information that's given to me. That's all I want to use to find this. So I say to myself, all right, I have 3 trig choices, sine, cos, or tan. And it's going to be dependent on what I know. So I know this angle right here, right?
Yes.
And I know that side. What is that side of my triangle? That's my hypotenuse, correct? And where is this side in relation to that angle?
That side would be
Adjacent, Harley. So which one is adjacent and hypotenuse, Harley?
The hypotenuse, or Z and X.
No. Which trig function? Which of the 3 trig
Oh,
functions? Sine, cos, or tan?
Cos.
Is it awesome? Cos is adjacent over hypotenuse. So here's what I do.
Yes, okay, I get it.
I do not.
So I go cos 30 degrees equals. I'm looking for that side. Hey, watch. I'm looking for that side. It's adjacent to that angle. I'm given that side. It's the hypotenuse. So you have to decide, is it sine, cos, or tan that deals with adjacent and hypotenuse? In this way, in this situation, it's cos. In every situation, it's cos.
Because it's at the bottom.
No, because it's next to the angle. This side's across from it. Therefore, it's the
Oh,
opposite.
yeah. Okay.
Okay? So I've got cos 30. What's the side adjacent to it?
10.
No.
No, X.
X is. What's the hypotenuse?
10.
10. So now what you need to do then is solve for X. So you take the cos of 30.
And
Now you get the 10 away from the X.
Times it.
Times it. Very good. So take cos 30 times 10.
So 3.5.
8.66.
Oh, that's wrong. Never mind.
8.6. Give me 3 decimal places.
660.
Why did I get 0.5?
Yeah, me too.
Why did I get?
Okay. Now, let me just point this out to you. Calculator-wise, you should punch in your calculator like this. 10 times cos 30. All right? Because what you're doing is you're going to cos of 30.
Oh, yeah, that's... Because I did cos 30 times
So
10.
then it took the cos of 300. That's how come you got 0.5.
So you
Alright.
got 8.
Yeah,
Oh, I got it.
8.66025.
No.
Okay?
No.
So how, like, if it's 300, then how is the cos, like, smaller?
The cos
than
of
it's
300.
Because it's the degrees here.
Oh, yeah, okay.
Yeah,
degrees of
yeah. So the
angle.
calculator read it as cos of 300 degrees.
Wait, could you leave that
Okay.
up there? I'm just gonna...
I'm gonna leave it up here. I'm not going anywhere. Okay, so that's how I calculated my X value then. Everybody okay with that? So let's calculate Z next. Looking at my angle 30 degrees here, where is Z in relation to 30?
Just
Opposite. And where is 10 in relation to 30?
Adjacent.
Still the hypotenuse.
Yeah, oh.
Doesn't change.
Okay.
X.
Okay? So now I'm talking about opposite and hypotenuse. Which trig function is it? Sine, cos, or tan. Opposite and hypotenuse.
Sine.
Sine.
Sine. So I go sine 30 degrees equals Z over 10. Okay, put it in your calculator.
Sine codes and divided by 10.
I got 5.
So how would I?
What did I get?
10 times.
Oh, okay. That makes sense.
10 shift
Sine 30. There's no shift.
sine 30. Oh no.
Close the bracket and times it by 10.
10 times cos.
If you're putting the sine part first, you have to close your bracket. Okay?
Oh, every time I press the lead.
here.
Yeah.
30. Close the bracket.
But how do I do this?
There you go.
You got close the bracket. Sine, like I
It's
trying
just
to
easy
do
to
it, it's not
do
working.
first.
Everybody get that on their calculator. If you can't, I need to know so that I can show you how to do it.
Or I mean, 30 times.
Are you closing your bracket?
Who's getting two?
No, not second function sine, just sine. Yeah, there you go. Times 10.
30.
You didn't close
Oh,
your
like
bracket.
that?
I did. You gotta close your bracket.
Do it again. Do it again.
So
Okay.
sine 30.
Close your bracket.
I like that I don't have to
How
close
come
it.
it won't let me close it though?
Oh.
Close bracket.
I just like because I don't have to close it because it's just
Okay,
it's
try
3-0.
doing
You know what to do?
Yeah.
sin 30.
Right, closed bracket there.
times
This is yeah.
10 times.
Good.
I don't know.
Look and look, it'll work for me.
You okay?
No, we can't figure out this.
Times sin 30.
Just because
Fine.
Ian doesn't have
Say sin.
the exact same thing.
Let me see how you
They all
punch
just
it.
to the Ian, you can't spread the
Wait,
word.
wait.
Spread the word.
That shit?
No,
That's not this.
you don't have to.
You don't need shit.
That's probably why.
Someone printed it all out.
Yeah.
No, okay, let me, alright, I'm gonna clarify that because that happened twice now.
Yeah.
The only time you use shift is if you're looking for the angle itself.
Oh.
That's the only time. Now, I want you to look at the board. Look at the board for 1 second here. Okay? Look at this board. I want to check to see that I got this right. I'm pretty sure 60 is right. We have a pretty good idea, right? So how do you propose I check to see if the rest of it's right? Besides, Harley?
Would you use like times or add x squared, so 8.66 squared plus or 5
Yeah.
squared, and then should equal.
Yes, very good. Take 5 squared and add it to 8.660 squared. And what should it equal?
10 squared.
10 squared, which is
100.
100.
Yeah, pretty close. It's 99.9956.
Oh, I got 216.5.
Did we get it right? We got it right. Again, when you're doing these questions, you can always check your work at the end and make sure that you got it 100% correct.
It's good. I got the same. I got different.
Nowhere even close.
You're multiplying and not adding.
I hit the multiply.
How are we doing? We okay? All right. So, what I'd like to see you do tomorrow, you're not getting a lot of time today, and it'll depend on how Mr. Langstaff's day is going, but I'd like your instructions to him are to get through 8.1 to the mid chapter, which is going to take care of Pythagoras' theorem. All right, just adding angles together, Pythagoras' theorem, and the sine ratio only. So that's what the instructions are. Okay? Questions, comments? Getting started, you should do that on 212, 213 as well. All right. That's all I have for you going forward now until tomorrow.
What is that